In this conversation, we're going to be limiting our paddle so it cannot go off screen using mathf.clamp. Let's start by jumping into paddle.cs, our script, and we have currently vector2 paddle position as a variable. I'm going to change this a little bit where I'll just have our variable when we're creating our new vector2, all it's doing is saying transform.position.x and transform.position.y. It's saying in this line here, I just want you to stay where you are. I'm not doing any specific moving because I'm going to put moving on a new line so we can be very clear with what's going on. Okay, that's creating a vector2 at our x and y position, and then in this next line, we'll do some moving. What will that moving be? We'll say paddle pos.x. to identify that we're only interested in changing the value within paddle position, of the x value. We're not worrying about y, it's not going to change, but we would like to change x on each frame. What are we going to do there? Well, we're going to use something called mathf.clamp. And I've given you a link to this documentation against the lecture. Mathf.clamp is going to use the value we're interested in. And what is our value? Our value is going to be the mouse position in units. So where is the mouse on the screen? Therefore, where is the paddle on the screen? And we're going to tell it what is the minimum that the value can be and what is the maximum the value can be. In other words, where can this be on the left and where can it be on the right of the screen? So we have our line ready to complete mathf.clamp. What I'd like you to do is have a look at that documentation that I provided for you and to jump into your challenge, which will be limit the paddle's movement. So use mathf.clamp to stop the paddle going off the screen, serialize the variables for min and max so they're not baked into our mathf.clamp method, they're actually serialized, and jump back here when you've got that done. Okay, so mathf.clamp, we start by typing mathf.clamp, and in parentheses, what are we looking for? Well, mouse pos in units is the particular value we're manipulating. The minimum we are going to set as a variable we haven't created yet. We'll call this min x because it's on the x-axis and it's the minimum x, and we'll have a max x as our maximum. So we need to go and create those variables. And just a note, I'm going to put a comment up here to say at the top of our script is where we put our configuration parameters. So I'm going to write up here configuration parameters. You can see here we've got our screen width in units, which is a configuration and it's a parameter. Underneath our little heading we've just created there, serialized field float. We're going to create two floats. The first float will be min x, and I'll initialize this at the value that I think it should be, which is 1. Why do I think it's 1? Well, if we have a look at our paddle over here, the paddle is a width of 2. I know the midpoint is right in the middle, so when we get to the left extreme, i.e. the minimum, then the position should be at 1 for our x-axis. So 1f, and then I'll create a second variable, serialized field. It's also a float, max. I was going to say min y for a second there, that's not right. Max x. What's the maximum we can allow our value to be? Well, that's going to be 15. F, semicolon, same logic over here, that when we get all the way to the right, we want to go bonk and not allow our paddle to move any further than this particular value getting to a value of 15. Okay, so 1 of 15, excellent. That's all looking pretty good. Max x, what have I done wrong here? That should know what's happening. Oh, I accidentally hit a capital M. Never use capitals for variables. What on earth was I thinking? But you can see, so good that Visual Studio was giving me the red squiggly line. Save, jump back over into Unity, click on play. Oh, we'll make our game window a bit bigger first as Unity takes its time to compile my scripts. Open up. Click on play, see if I can move the paddle back here. Okay, we can move our paddle left, blunk doesn't go any further, and right doesn't go any further. Excellent, we have successfully clamped the movement on the x-axis. Just show you the script one more time in here. We added the extra line to say that the paddle position's x value, and we've got paddle position just above here with its x and its y. The x position, we don't want it to go any lower than min x or any higher than max x, and we've initialized that at 1 at 15, and we could change those over on our paddle. If we scroll down, you can see 1 and 15. If we were to be crazy, we'd say from 5 to 10. Play that, and then we know that the paddle isn't going to make it anyway further than the 5 and the 10 values, so it gets locked in those positions. So that's a great way for us to limit the movement of game objects in Unity. Great work, and I'll see you in the next video.